Hi all, I'm Kate Gorman. I'm a PhD student at North Carolina State University. First off, I'd like to thank the conference and workshop organizers for allowing me to speak today. I'm incredibly grateful for the opportunity. My research interests include native bee diversity in urban systems and its relationship to ground nesting resources and socioeconomic status. Specifically, I am interested in how urban yards shape urban bee communities. Today, I'd like to talk about the bee trapping methods that I have used in order to investigate some of my questions, in particular, how emergence traps can be used in urban environments to find bee nests. For the past two sampling seasons, I have been using e-traps and hand netting methods in order to gather information on bee communities in urban yards around Raleigh, North Carolina. My sites are all similar in size, but vary greatly in demographics and income. So some of my sites are highly landscaped, like this photo on the right, and others are a bit more freeform in their landscaping, like this photo on the left. I actually just finished my 2022 field season 2 weeks ago, and I'm beginning to comb through my data. Emergence traps are a great tool to find ground nesting bees as they emerge from the soil. They're staked into the ground like tents with a collection bottle at the top to trap any bees emerging from that 1 square meter patch of soil. Many studies have found them to be successful in capturing bees, such as the Sardinias and Kremen study. I'd specifically like to highlight the study from Ulishan et al. In 2021, which showed that keeping the traps in one place for an entire season is not nearly as successful as moving the traps around within a study site in order to capture the current season's nesting bees. So in 2021, I chose 30 residential sites around Raleigh where the homeowners were kind enough to let me sample in their yard. Here are a few examples of those sites featuring the emergence traps. During this first year of sampling, I quickly became aware of my limitations in this study. Most importantly, the traps were deemed unsightly by some of the residents, so they were quite opinionated about me placing them front and center in their yards, understandably. They also often left a square of dead grass behind when left out for weeks, so moving them around and creating multiple dead patches was a non-starter for many residents. Since these people were kind enough to offer their private property for my research, I really had to comply. In the 2021 season, we trapped bees using e-traps and hand netting from June to August. A total of 50 traps were placed randomly across sites and stayed in the same location all season, while we collected samples every 3 weeks. We also conducted hand netting 3 times at each site. I used the random points tool in ArcMap version 10.8 to select the random trap locations. These e-trap placement methods resulted in over 100 trap samples and only 6 bees. This means that 1.8% of traps captured bees. Even though the traps were unsuccessful, we did end up finding some nests. In fact, we found 13 nest aggregates in total, 2 from the traps and 11 from our netting protocol. We conducted hand netting at each site for each sampling period for a total of 40 minutes of effort. And while doing so, stumbled across the other 11 nest aggregates that we were able to collect bees from and confirm that they were in fact ground nesting bees. Here's an example of a small lacy blossom nest that we stumbled across at one of our sites. And here's our confirmation. We were able to catch this bee for identification. So we decided to try something new. For the next field season, while conducting our netting protocol where we collected foraging bees, we also kept an eye out for potential nests. These were marked with flags, and then we returned another day before 9 a.m. in order to set up a trap over the potential aggregate. When intentionally looking for nests, we found 77 potential bee nest aggregates, each of which was covered with a trap for 3 to 7 days, ensuring at least 3 days of favorable weather while the trap was deployed. This change resulted in 955 bees in our traps. About 38% of traps captured bees, and we collected fewer samples. We found that samples that did not contain bees usually contained ants or beetles instead. So the differences from 2021 to 2022 are quite staggering. Surveying them for nests, then placing traps over them allowed us to confirm if we were actually finding bee nests and then capture and identify a much greater amount of bees that were nesting in these 30 urban yards. In conclusion, based on these results so far, it might be unwise to keep e-trap stationary throughout an entire season unless you're specifically looking for last season's nests. In addition, we are presented with a different set of limitation in urban studies, such as resident preferences. Moving the traps continuously might not work when you're working in a highly managed space. Lastly, e-traps are quite effective in confirming the presence of bee nests when surveying for them. I'd like to thank my advisor, Elsie Youngstead, and a few undergrads and other lab members for helping me gather this data. Thank you all so much for your time.